Hello everyone, welcome to the channel. I hope everyone is doing good. So in today's video, we are going to discuss about the EMR. So this is going to be a theoretical session. We'll discuss about the EMR architecture, EMR working, and some of the features of the EMR. In the next video, I'll come up with the practicals of the EMR, where I'll demonstrate the Spark execution in the EMR. The full setup will be done in the video itself. So let's start with the EMR theoretical session here. So we should, before doing the practice of the EMR, going into the practical things of the EMR, we should always know about the architecture and some of the basic component of the EMR. So this session is basically focused on this part. And guys, if you have not subscribed to my channel, please subscribe to the channel and please share this video to your colleague, to your friend who want to move or who want to transition their career path into data engineering field. So let's start now. So EMR is one of the service in the AWS, one of the very important service for a data engineers for a computation part. So EMR stands for Elastic Map Reduce. So we generally do, or we generally ask the EMR to do the distributed computing, like your Spark, Flink. So these all can work on the EMR effectively. You can normally run a normal Python program also in the EMR, but the purpose of the EMR is for running the distributed computing. So we already have a EC2 machine. So if we have to create a cluster, like in the cluster, there are multiple machines connected to each other. So if we have to create a cluster, we can combine multiple EC2 machine and create a cluster, and then install all the Spark binaries, Hadoop, HDFS binaries, all the stuff which we require for the big data ecosystem. But that is time consuming. Most of your time and energy and the resource will be invested or wasted in the infrastructure thing. So AWS has come up with one of the services which will build your cluster in few minutes, and you can utilize your resource. You can utilize much of your time on writing the program, on writing the logic transformation on the EMR. So EMR is the combination of multiple EC2 machine which creates a cluster, and it also has the set of binaries, and each version of the EMR has a set of binaries which will have the Spark version, Scala version, PySpark version. It will have the HBase version, or all the ecosystem component which is required in a big data will be there in each version of the EMR. So EMR also comes in a multiple version. So currently the 7 series of the EMR is running, and it has like you can also customize your EMR like which software you want. So EMR gives the biggest advantage that you don't have to just select each component of the Spark Scala version and install in the machine, because that is very difficult and it's very confusing also sometimes. So just select the EMR version. You can tweet around which software you want, which software you don't want, and then you can create the EMR. That we'll see in the next video. So currently we are focusing on the EMR theory part. So what is EMR architecture? So generally people ask the architecture question around the Spark, but I have seen in multiple client interview, which is where the job is heavily focused on the EMR side. The client ask about the EMR architecture. It's a simplified architecture, but we once should know that what is there in the EMR architecture, what are the different components. So architecture means you have to tell about the component, the purpose of that component, and how this component combined together gives a solution to any of the problems. So EMR generally have three component. In this diagram, I have just copied it from the Google image. So in this diagram, only two component is there. One is master node, one is core node. But there is a third component which helps in the distributed processing, which helps in scaling your cluster, is the task node. So there are three kinds of node in the EMR, AWS EMR. The first is master node, the second is core node, and the third is task node. So if you go down, I have written it here. One is master, core, and task node. Master node is the resource manager node. Like in the normal Spark, you would have knowing about the Yarn as a resource manager, Mesos as a resource manager, Kubernetes as one of the resource managers. So here, the node itself is a resource manager. It manages the cluster. It looks into the health of each of the node. If a node is not working, if a node is not live, then the node will be taken out of the cluster. All the cluster management services is done from the node, and this is a single point of failure of your EMR cluster, but there are still the backup of it. There are multiple ways to deal with that. We are not going into that detail, but master node, it manages the cluster, it coordinates the job and resource allocation. Whenever any job is submitted, master node responsibility to do the resource allocation for that container. Then it runs the Yarn resource manager. So we are talking about generally Yarn. So I have written it here as a Yarn resource manager, but you can have any other resource manager. The other important is the core node. So core node runs the task. When you create an when you submit a job, the executor will be created. It will run in the core node. I'll come to the task node now. But let us understand, like in the core node, your job will be executed. Your data will be stored in the core node. So your HDFS, S3 and all this stuff will be there in the core node. Core node will contain the data. It will participate in parallel processing. That means the executor will be running on this, the task will be running on this, and it is required for the cluster stability. Obviously, when the core node is not there, then parallelism will be will fail in that case. Now these two are the important and necessary part of the AWS EMR. But if you want to scale your cluster, so you need more helping hand, you need more compute layer. Compute means CPU. So that CPU is provided. Either you can add a core node, but that becomes a bit costly. I'll come to that. So you can add task node. So as per you, like for example, today around 10 o'clock, you have like there's a sale in your website and you need more of the cluster execution performance. At that time, the scaling up will be done by the task node. In the task node, only you can compute the task. Then the see you we don't have to connect to the task node separately. That will be done by the internally by the AWS EMR. But your task will be distributed to the task node also. It will not contain any of the storage, so it do not have the HDFS in its data in its node. So it only participate in the parallel processing. This can be added, this can be removed as per the scaling out and scaling in. Okay, so that core node we generally don't take out. Once the cluster is created, master node and core node is the main component which will be there till the lifetime of the AWS EMR. But task node will be added, it will be deleted as per the workload. Okay. Now, all nodes typically run on the EC2 machine, as I have told in the starting of this session, that in AWS cluster, AWS EMR cluster, the cluster is made with the machine, and that machine is the EC2 machine. And the biggest advantage of the AWS EMR is like the storage and the compute is separated. So EMR separates storage and compute, because storage you are doing in S3 for the persistent storage. For temporary storage you do in the computational storage you do in the HDFS. So that is being separated with the compute thing, right? So this is generally the advantage for the any big data ecosystem. Only it's not very much fixed with the EMR itself. It is it is a general for all the distributed or parallel processing. Generally big data or the Spark, when you work on independent server, not in the cloud, there also this advantage will be there. Now we'll move to the other part, which is the storage. What are the different storage options, choices available in the AWS EMR? So basically there are three kinds of storage choice. The first is Amazon S3 bucket, which is very common. The other is HDFS, and the third is the block, your disk block, Amazon EBS, the block size, block disk. So S3 is the persistent object storage. That means if you delete or if you decommission your AWS EMR, then also your data will be stored in the S3, because S3 is another component of the AWS services. So your data will be stored there. So we are calling it is a persistent object storage. And the same thing is written in the second line. The cluster can be terminated without the data loss. It supports the file system, which is EMR file system. Okay. The other is HDFS, like we know, Hadoop distributed file system. So this will be inside the cluster where you need a high performance. Means if you want the the storage in between the transformation, if you want the caching to be done, that will be done in the HDFS. Once the cluster, for example, if any of your core node is down and it has the storage of HDFS, then the all the data stored in HDFS will be also deleted. So data lost when cluster is terminated. The third is EBS. It's a block, like how we mount a hard drive or any drive to your system. The similar way AWS EBS is there. So when you create a node, you can add an external storage with the help of EBS. This is also a persistent, and this cost a lot. This cost it will be additional cost to your cluster. So it is used for shuffling and intermediate data itself. Okay. So mainly people use most of the cases. The people will be using S3 bucket itself. Okay. So this was about the storage choice. Now there are framework like these are the ways of of distributing the framework in AWS EMR. The first is the processing framework layer. So like which all framework will help in the computation processing or distributing your task or doing the parallel processing. So Spark is one of the framework. Hadoop MapReduce you can run in the AWS EMR. You can run the Hive, you can run HBase, you can run Flink. Now, how you will submit the job in the AWS EMR? So we call it a job submission layer. So that can be done directly with the EMR console. That can be done with AWS CLI command line when we connect to the AWS. That can be done with the step function, Lambda function, Airflow with the Airflow, or there is a managed Airflow of the AWS with the help of that. You can schedule the job. You can also use the notepad notebook and connect to the AWS EMR and you can run the job. So two kind of framework is there. One is helping in doing the job, and other way is how you can submit the job. So how does Spark run on the EMR cluster? So when we talk about the EMR cluster, we are mainly telling about the Spark, how you are going to run the Spark on the EMR cluster. So once you do the Spark submit, driver starts on the master node. So when you see the architecture of this, so there is a master node. When we discuss about the master node, the first and the main component of the AWS EMR. So when you start the Spark, does the Spark submit with the help of any of the job submission layer? Your driver will start on the master node. Yarn will allocate executor on the core and task node. So your executor, your work is done by two kind of node. The first is core and the second is the task node. So executor allocation will be done in these two nodes, and executor will read directly data from the S3. So the core, one is the master, the second is the core, and the third is the task. So the core node will contain all the data, and executor will read all the data from the core node. Mainly it is the S3 bucket, so it will read from the S3 bucket. So this is how a very simplified way. I'm not going into very detail of how this Spark runs on the EMR cluster. So this is very simplified way how this Spark runs on the EMR cluster. In the next video, I will be coming up with the EMR cluster creation. All will be practicals in which I'll do the setup of S3 bucket, we'll do the setup of Spark submit with the parameterization, and then I will execute the Spark on the cluster, and that will be interesting to watch. So if you have not created your AWS EMR free account, please create the free tier of account so that you can just go through my video and do it practically parallelly with me. Now we are coming up with the coming to the very important point, EMR costing. So how much cost, in which ways EMR charges you? So first of all, in all the AWS services, the charge is based on per hour. Till the time you are using it, you have to pay it. If in S3 bucket you are storing any data, till the time you are storing the data, that much payment you have to do. Now EMR costing generally comes from the four component. First is the EMR service fee, surcharge fees. That compromises of 5 to 10% of your EMR total EMR costing. The other is AWS EC2 instance. That cost around 70 to 80%. EBS volume, which I mentioned here in the storage part. This EBS, if you are using it, you will be using it obviously. So that will have 5 to 10%. S3 storage, the other storage thing, that will be 5 to 15%. Now you see the maximum cost comes from the AWS EC2 instance. So you decrease the number of working hours of the EC2 instance, your cost of the overall cost of the EMR will decrease. Now we'll discuss with a simple example. Like for example, this is my cluster configuration in which I have a master node, I have a core node task. Master I have a 1 node, core I have a 3 node, and task node I have a 6 node. So master I have this machine M61X large, and in the core and task I have R6i 2X large. So master and core will have on demand. On demand always have the higher cost. As master and core is the main component of AWS cluster, so we have kept in the on demand, and the task is on spot node. So this will cost less. So task node is basically on scaling, scale out, or if you are not getting six task node at the starting of your job, then also your cluster AWS EMR cluster will work. Now, if you don't understand what is on-demand spot, you can go to my previous video of AWS series and then you will get to know about this. Now, I've written here some of the charges which I got it from the Google. Like for this machine R6i, on demand will cost around $0.5 per hour, and this is per node also, not for a cluster, per node. Similarly, for the same machine on spot, it's cost $0.15 per hour per dollar per hour and per node. Similarly for EBS, 0.1 dollar per hour per node. EMR surcharge is 0.07 dollar per hour per node. Okay. Now we'll do the mathematics and we'll just see that hourly how much this configuration of the EMR will cost you. So if you see here, hourly your core node is 3 node. See, on demand will cost around zero point 0.5 dollar per hour. So 3 into zero point 0.5 plus 0.07. This will be your surcharge for the AWS services, and 0.10 is the EBS volume if you are adding it. Okay. Then we have a master node, one node. So it have M61, M6i, I have not added it. So it will cost around $0.25. So 0.07 for the surcharge and 0.10 for the EBS. So this will cost this much. Similarly, for this is for the task node. We have 6 task node. So 6 times this is the spot. So spot for the same machine will cost 0.15. So spot always cost less. You can see that the same CPU size on demand is $0.5 per hour, and the spot is $0.15 per hour. So the spot is always cost less. So 6 times of the spot plus surcharge plus you have the EBS volume. So it comes this one. So we'll get fairly a fair idea like how this is being calculated. If you want to create any dashboard for your cost optimization, want to see the cost on a daily basis or in a week, in 2 hours or 3 hours, so that can be done in this way. This formula you can use it, or this way you can use it. So mainly you are paying for the EC2 instance, and for that, if you reduce the EC2 hours to, you can make the EMR costing cheap. Okay, that we've discussed. Now we have something called a basic type, like what, how, with the basic steps. This is not very much descriptive, like what are different ways you can cost optimize the EMR. So by using the spot task node, so we have seen like while using the spot, your charges will be less. So if you're using more of the spot, but spot is used for the task node, so that will reduce the cost by 60 to 70%. Ephemeral cluster in which you can, like for example, you created an AWS EMR and don't keep it running for whole day or whole week. You spin up the cluster, means create the cluster, run the Spark job. When your Spark job is run, then terminate the cluster. So you need to pay for the cluster only for that time, till the time you are running your job. So this way generally company does that. And for this we have a different kinds of cluster also come up in the market for the EMR. The EMR have different types. We'll see now. Instead of HDFS, use S3, which is a bit cheaper, more performance, persistent storage. Okay. Now, the types of EMR. Generally, there are 3 types of EMR. The first is persistent, the second is transient, and the third is serverless. So, persistent EMR is the EMR which generally we use in a normal work. If you are not specifying a kind of EMR, then the persistent is one of the EMR in which the server is under your control. EMR will be on for whole day, whole week, unless until you terminate it. You have to take care of the scaling of server. You have to take care of the health of the EC2, and you have to pay for whole day till the time that your cluster is done. Like it means that the full control is on you, with you for the. So for the full control is with you for this EMR cluster. Transient, in transient what happens if you, once your job, all the steps, like we give the, for example, we are running the job in a step function, so multiple steps are there. After this Spark job, we have to check particular return code or particular output, then the second job will run. All the dependency series are there. So once all the steps are run, then the transient cluster will terminate itself. So you don't need to take care of terminating the cluster. The transient cluster will itself terminate it. For the scaling the cluster size, you can give the number, like till what maximum number you want to scale. That can be also done in the transient cluster. We'll see all this practically in our next session. The third and very recent is serverless, in which there is no server. Means that there is a server in the background, but the server is not in our control. We don't have to look into the server. We don't have to know about the server. You submit the AWS EMR cluster, it will be running instantly. The server will be available, it will be running instantly. So if you have a very ad hoc job for less amount of time, you can use serverless. All the scaling out, scaling in will be done by the AWS. So there is no headache of any kind of admin work in this case. You can directly use the serverless. But the disadvantage, it cost. high than other thing. There is no additional cost of your associates, but there is a cost of the EMR here. Transient is used when you know that at what particular time your job is running, when you have a full control of your job. Persistent is like for the testing environment, when you are a small cluster, you want it to be on, like people are working on this cluster for longer period of time. At that time, you can use persistent cluster. I hope you would have got the fair idea about what is EMR, what are different things around the EMR. So whenever you now you go into any of the discussion of the EMR, you will be knowing about the cluster. You can deep down into this detail. You can go on Google and search it more detail in AWS document. Also, you can learn it. In the next session, I will come up with the AWS EMR, all the practical things which I have already told in this video. If you have any doubt, please mail me, connect me through LinkedIn. We can discuss there, or you can post your doubt in the comment there. Also, I'll come up with the solution. Till then, happy learning and take care.